from there, when the keynote starts, they usually have some crazy Rube Goldberg type of thing happening, and it went all the way around the room. And at some point, it turned into like CGI with a fake whale. But until the CGI, it was really cool. You know, like a ball falls down, and it turns, it hits a switch that causes a fire, which burns the string. You know, all sorts of crazy stuff. Yeah, so that's really cool. And for those of you who don't know, I/O is Google's big developer conference once a year. Typically, it's about mid-year, so March, April, May, June-ish. They don't usually tell you ahead of time, like very far in advance when it comes out. We'll probably find out around December this year, is my guess.
Is it insane to get tickets, though?
Yeah, it's insane to get tickets. So you basically don't expect to get tickets. It took me years to get tickets. Actually, I don't know if I've actually officially ever gotten a ticket. It's always been through GDG, in fact. I don't think I've ever been able to actually get one. They get just one part of Moscone Convention Center in San Francisco, the smallest part, actually, Moscone West. And I think half the tickets are reserved ahead of time. So if there's 6,000 attendees, let's say, 3,000 are generally on sale, and 3,000 are reserved for partners and various other people. So the whole world tries to go. There's 3,000 tickets. Yeah, it's kind of tough. But most of the sessions are recorded, and so you can watch them. And my experience this year was that it was a lot harder to get on sessions than in previous years. So, and even if you got into the session, it doesn't mean you can necessarily see or hear. So in a way, it's almost better to just watch it at home at your own comfort. There's always some live stuff too, yeah. And all the code labs are available as well, so it's not like there's something exclusive that's only there. Pretty much everything that's done there is now available online afterwards within a week or two. So yeah, it's hard to kind of justify the trip. And if you ever try to do a trip to San Francisco, the hotels are extremely expensive, especially during a conference. So you have to really want to go.
Yeah, they're sold out. I remember that.
Right. Yeah. Dreamforce, everything sells out like crazy. $1,000 a night for Dreamforce. Yeah.
He literally got me the last room.
Yeah. So yeah, for Dreamforce, I actually fly up for the day and fly home the same day. I never will stay overnight. Last year I stayed overnight because I had a really early presentation, and so I stayed in San Jose.
Okay,
and then I took the train up. It was a nightmare. And the place I stayed in San Jose was disgusting. I would never stay there again. It was the only thing I could find. So you get like a 40-mile radius of everything being sold out. Yeah, that's a bigger conference, because that's 150,000 people. This is...
The head of Google, too, somebody said he didn't get the highest VIP.
Yeah.
So people were like, you can't go up there.
Yeah, no, conferences in San Francisco are crazy. So, not going is okay. You probably will enjoy it more not going. And it's very frustrating. I was there and I was like, I can't get into that room. That room is full. You had to wait in line an hour before it started, but I was in some other session during that hour. So it's okay to watch online. Yeah. Okay, so we are at the 2 o'clock hour now. So we're going to be starting in the main auditorium here with augmented reality with JavaScript. I'll introduce Zeno in a second. Just want to give a advertisement for the how to build your own anonymous video chat application over here in Breakout A. We have two speakers from, oh, they're not there yet? Okay, they'll be there in a minute. Yeah, Alex and Will, you just kind of got to wind your way. If you're interested in that, and literally they're going to show you how to build it. So that's going to be in Breakout A. In Breakout B, all the way in the back corner there, we have the member app presentations, and if you want to give your own presentation, you're more than welcome to also. We still have pictures going on over at Cloudspin, and hacking wherever you want to hack. Okay, so with no further ado, we have a repeat speaker. We're very lucky here. Zeno spoke at an event in, when was it, July, August? A couple months ago. Packed room. Could not have fit more people in that room. It was an awesome talk. I'm still in awe over the light stuff. That was so cool. So I don't know if you saw that. We have it online. You should look at it. It's really cool. So Zeno, come on over. Begin your talk. Let's give a round of applause for Zeno.
Hello, everybody.
Hello.
Come on, hello. We're sleeping or something?
Yeah.
Cool. Yeah. Awesome. So today we're going to talk about crazy computer vision in the browser and what that means, right? Like, what are we here listening to that kind of thing? In the end, what I'm going to talk, it's really HTML, CSS, and JavaScript. Nothing more than that. So here's my Twitter. If you want to send any questions, if you have like anything you want to ask, just ping me on Twitter, and I'll be more than happy to answer you. I work at LifeRay. It's a company in Diamond Bar, not so far from here. And I also do some projects with Google as a Google Developer Expert. And I'm from this little town over here in the south of Brazil. That's what I'm from. And you know, like Brazil, like soccer, you know, Carnival, World Cup, all those things. That last one didn't work out so much for us. But I'm super happy to be here today. LA, you know, Hollywood stuff. Tuesday, so nice. Oops. Okay, that one. Okay. And my idea with this talk today is for you to live like this. That's my plan. Like, I want to show some really crazy stuff, and that's my goal. Let me just come over here. So what is computer vision? What are we talking about? What is computer vision? Basically, the idea is simply having our computer to see something. And when the computer sees something, we want to do other thing. Okay? It's that simple. There are many ways we can do that. But first, I just want to recap like how the vision works. So we have our eye, and when we look into something, like the lights that reflects in an object goes through our retina, and then it is inverted over there, and then that image goes right to our brain. And then we see that image, and then our brain detects that we see that image. That whole process takes like some seconds, and that's the persistence of vision. That's how it works. And because of that, we can do things like movies, right? So motion perception is simply having lots of images that are shown like really, really fast, and then we think that is moving, but it's not moving. It's just a series of static images. That's how people make movies. That's how people make animations and all that, right? So it's simply tricking our eyes, basically. And there's many things that we can try to do with computer vision. Many things that you can apply to. One of them is face detection. Face detection is you have an image and you try to detect a face on this image, right? Face detection. There are lots of different things on those images, like the color of the skin, the hair, the distance of the eyes, the mouth is open, is it closed? There's a lot of things that can differ, and you need your computer to detect that this is a face. For us, it's okay. We can see that there's a face over here, there's a face over there, there's a face over there. But how can we do, and what can we program to make computers detect faces? That's a pretty hard challenge. Another one is face recognition. It's a different thing. So do you guys recognize who is on those photos over here? Can you see it? Johnny Depp, right? It's the same guy in all photos, but it's really hard, even for us, to see that it is the same guy. There's a lot of different things going on, and you need a computer to identify that this is Johnny Depp. When we're using Facebook and we upload our photos and boom, your face is detected and then it's recognized as well as you or your friend, for us it's like, okay, you accept and it's no big deal, right? But having your computer to make this is pretty hard. There's other types of things that you can do with computer vision. Another one is autonomous robots. So there's this World Cup of robots. This one was in Germany, and you have like a robot and you have a camera on it. Nobody's controlling those robots. is just like they're just trying to play by themselves, trying to identify where's the ball and trying to hit the ball.
Almost as good as the Brazilian team, huh?
Exactly, almost as good as them. And, oh, this is my favorite moment. Wait for it. Yeah. So that's pretty awesome, right? Like having robots to play soccer is pretty crazy. Another one is virtual reality. Virtual reality is like you have a virtual image, and with your movements in the real world, you project something in this different reality. This is another application. And augmented reality, it's the opposite. Like when we see Iron Man and he puts his suit and all that, and now he's gonna like look to a real scene, but other stuff is gonna be like plotted in this image. So you're putting computer things into a real scene, which is the opposite of virtual reality. But how can we do all that? We have all those different fields and all those different applications for computer vision, but how can we do that in practice? There are many different ways. One project that you can use is called R2Kit. It's in C++, it's on GitHub, and there's a fork from that project called FLAR2Kit for Flash, and then there's a different fork for JavaScript, and you can do that. There's another one, this one is probably the most popular. It's called OpenCV, and it's in C as well, and you can use it. But how can you do that in the browser? There's a lot of people and there's a lot of work being done in C++ and other backend languages, but how can you do that in the browser? And how can you do that in an environment that it doesn't have that amount of computing power and it's not as powerful as running in C, right? It's pretty challenging. So how can we do that? The first step is the most obvious one, right? We need to access our camera. So I have my computer, there's a webcam over here, and I need to access the camera. That's the first step. How can we do that using JavaScript, using web technologies? There's a new W3C specification called Media Capture and Streams, and they have this API called Get User Media. So the way you request the user's webcam is by calling the navigator.getUserMedia, and you have two options that you can pass. One is video, another one is audio, and then you have success and fail callback. You have two functions that you can call and then behave and do something with those two functions. So that's how you request a camera. The second step is reproducing the image that you see on this webcam in a video. Because I have a streaming going on and it's detecting some images, but I need to put that on a video. So how can you do that? We can use the HTML5 video tag. So we can use that, and on that success function that we got from the getUserMedia, we can query a video, create an object from that stream, from the webcam, and then do something. Show that image on the video. So now I can get this string from a webcam, put it on a video, and then I can see it. The third step is detecting the pixels from that. So you need to get the pixel matrix from every single frame from that video. And we can do that by using the HTML5 tag canvas. And then the fourth step, the last one, is the tracking algorithms. Now that you have your image, now that you can detect the pixels from your image, how can you actually detect that there's a face? How can you detect that there's somebody on that image? And this is the really tricky part. So all the other parts are steps that you can do, but this one is like the most difficult one for sure. So here's the summary. So we need to access the camera. The user needs to accept it, right? That's a security thing. because imagine people accessing our webcam without it, and you don't request it. So you need to request the camera, reproduce the camera in the video, and then you obtain the pixel matrix, and then you put it on the canvas, and then you apply the tracking algorithms. That's how it works. So that's a lot of steps, that's a lot of things to do, and we decided to create a project that wraps all that and tries to make it easy. OpenCV, R2Kit, all those libraries, they are really well implemented. They are really focused on performance and all that, but the API is terrible. And for the browser, there's no libraries at all. So we wanted something that was really fast, and the API was simple as well for developers. So that's what we created. There's a lot of people behind that project. I'm just here talking about it. But there's a lot of people like Eduardo, Maíra, Pablo, Thiago working on this, and there's a lot of like features. What are the main things on this project? It's in JavaScript, 100%. It's open source. It's on GitHub. There's no dependencies. Like doesn't depend on jQuery or any other Angular or whatever. The API, we tried to make it as simple as possible. All that setup, the video, getting the camera and all that, it's already built in. And the tracking algorithms, we are really focused on performance, and there's a lot of like regression tests. There's not many people doing regression tests, especially focused on performance. Basically what we do is, for every single commit, if there's something that, like I'm implementing a new feature or fixing a bug, but if that makes it slower, we detect and we like fail the build. So that's one thing we do. We're really focused on performance, and it's really small, like 7K just zipped. So that's the things. So here are the things you can do with that. The first one is tracking a color. What are what can we do with that? So here I have an image, and I have like whatever is going on this image, and I want to detect the magenta color, or I want to detect the cyan color. So the API is really simple. Like I create a new tracking, I'm specifying the color tracker, and then I have an array of colors that I can pass, like cyan. Now this image is gonna track the cyan color. Once I detect the cyan color, I have the matrix, and then I can plot whatever I want. In this case, I'm just drawing a rectangle here, so no big deal. So that's the hello world for the color tracking. We have the constructor, so you pass a color and instantiate this new color tracker, and then you want to specify what is the div, what is the selector from that image, and then we have this callback that says, okay, when it's tracked, I already detected some color, do something. And then on my case, I'm just putting a rectangle. The other thing we can do is detecting objects. How is that? Imagine I have some photo like this, and I want to detect the faces. So I need to read every single pixel from that image and try to figure out if that's a face or not. And not only faces, like we can detect different objects, like or different things. On this case, not even a face. I also want to detect mouths. Now I'm detecting the mouths, or maybe the eyes. Now it's detecting the eyes. You see that on this guy, it didn't detect the left eye. So I can just adjust the precision of my algorithm and try to make it as better as I can. That's pretty cool, right? How can you do that? So pretty much the same API, have the object tracker, and you need to tell, like from that case it was an image, but you can also detect a face from a video. So here's what we can do. So I have the webcam, and I'm putting on a video, and then I'm tracking that, putting my face in. So the code for that is simply like getting the ID from my HTML, the video tag, and then this is all I want, all I need to do to get the camera from the user. Camera true, and then once I have the camera, yeah, sure.
What is the currency and recall of face recognition?
Sorry?
What is the currency of face recognition, face detection?
What is the
Currency.
currency?
Yes.
You can adjust the precision. So this is like an algorithm called Viola-Jones, and the precision, I don't know, like a number, like 100% or 10%, because that really depends on the image you have. It depends on the lights, because if you can see here, if I go like a light that is not very good, it's not gonna detect, you know. So a currency, there's no like secret value to define that. Cool, and then you detect the face, and then you can put like a rectangle or do whatever. What you're gonna do in the end, it's up to you. In this case, it's a rectangle. Okay, so these are the Hello World. Pretty powerful, really simple API to do that. And you can also implement custom trackers. We can detect faces, we can detect colors, but maybe you want to detect car plates. Maybe you want to detect